Now coming back to other doubts, you sent something to me?
1 second.
About to send.
Yes, sir. Yeah, I sent it.
Aha. Okay, so this is why you asked me cyclic alkene at that time.
Yeah, this is the part of the fused bicyclic
Yeah.
compound.
I heard you. I heard you.
Yeah.
Now, that is again another unnecessarily complicated crap, which I would ideally not touch up. This will only complicate shit.
Sir, my doubt is like what type of isomers are there?
So let's talk now. So let's number, shall we?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let me name the compounds as well now. I'm going to call this guy as compound 1, compound 2, compound 3, compound 4, not compound, really structure. So let's start comparing each bugger.
Yeah.
So what do we compare? This pi bond is going to be having resonance. Yes or no?
Yeah.
So I'm going to be having this pi bond. The double bond doesn't always exist as a double bond. Resonance, na, basically it means for some amount of time it is in that structure, for some amount of time it is in a different structure. Correct? That means it becomes a single at some point of time.
Yes.
So it will have free rotation to an extent.
Yeah.
So there is no cis-trans applicable there.
No.
So all three of these suckers are the same.
So they're not geometrical isomers.
Yeah, they're all the same.
Oh, they're the same. Okay, yeah, they're the same.
Why?
They're the
Because
same
no
compound.
geometrical isomerism applicable.
Oh.
Right. What does geometrical isomerism require?
Restricted rotation, or yeah.
Basically, there has to be a pi cloud where you can't move around, you can't basically rotate around.
Or
You're going to be
ring,
having a fixed configuration necessary there.
Yeah.
Here it becomes single, no fixed nonsense. Clear?
Okay. Yeah.
Why? You seem to have still a doubt. What's your issue here?
Well,
my guess is it's probably going to be having to do with some answer which was given to you about this in school.
Yeah.
What's the answer given?
The first two are given geometrical isomers.
First two are given as geometrical isomers.
Yes. 1 and 2.
And they are telling you 2 and 3 are the same.
No, I mean, obviously they are, yeah, but like they're the same structure.
Okay, what to say? I'm not going to be agreeing or disagreeing on that right now. Mainly because that is something which will get a little bit more clearer to you when you end up learning a little bit more. Now, coming back to the remaining here, what was the explanation then for the remaining? All three are the same? 4, 5, 6?
No. 2 and 3, sorry, 3 and 4 is given as position isomers, and then 4, 6, 5 and 6 are identical.
So basically 4, 5, 6 are all the same, but 1, 2, 3 are different is what has been mentioned, correct?
Yeah. I mean, we're supposed to compare in the pairs given. So
now, I will not be agreeing with the point here, mainly because I know one thing over here which your sir is probably trying to teach you. Let's neglect that double bond O. Okay, I'm going to take this guy. If I take a double bond here like this, All right. And if I take, say, this, these two are cis and trans isomers.
Yes.
This is cis, this will be trans.
Hmm.
But not when there is resonance. Not when there is resonance. And there's one more point.
Then
There is one more point here to finish. I'm not done with that. This is possible only for total ring size above effective 8.
oh
Or
yes.
this is total 10.
Yeah.
You know that already.
Yes. Yeah. Yeah. He
So
was.
I already mentioned that to you in your class then.
Yeah. He told them. Yeah.
Not bad. Then I don't understand why he gave you this example. The logic there he's given is correct. That is correct. But no, not for not when there is resonance possible. When there's resonance possible, things will not be that simple. Resonance will take more priority. Resonance will change the game a little bit more. Effectively,
Then
during resonance, yes.
what must have we thought to assume that it was geometric?
This example,
Oh, okay. Yeah, correct. Yeah, yes. Yeah.
right?
Yes. Yes.
That is the example which he wanted to link up, but he didn't use it in that sense. The idea there is, my guess is he has told you about the 8-member ring being something which is non-planar properly.
Yes.
He would have discussed that example.
Yes.
And he would have talked about probably this boat fellow, maybe. I do not know.
No, we didn't do this.
Not yet. Okay. He will probably do it soon. Or maybe when he's doing cyclohexane, he'll probably discuss that. So the idea there is that system there, once you end up going into that 8-member rings and this planarity stuff there, the next level which is going to be straight away graduating over there is when you end up putting a double bond in that cyclo shit over there. If it's a 10-carbon ring, it will boil down to look like an 8-carbon ring without the saturation, without the unsaturation.
Yes, like
So,
in 2D.
Correct. So that's the advantage there. So that 2D projection is a very interesting question which you'll normally find in very good papers, tough papers. So
Like what
that
could they
is,
ask?
yes,
What could they ask exactly? Like,
pretty much what I just showed you. They'll ask different variations of this.
like whether this compound exhibits.
No, they'll ask you whether we can bend compound 1 and get it into compound 2.
Oh, so it's like think 3. Okay.
Yes.
Like an IQ test.
That's the problem there. When you recognize these are cis and trans, you know whatever bending you do is not going to help.
Yes.
So,
okay, so that's a key.
So that is the kind of, it is just, if I was asking questions, I would put it like that. But rarely will you find the bending nonsense and all being asked. Something similar to it will be asked along those lines.
Yeah.
So anyway, I'm assuming then this part is clear here then, yes?
Yes, that's fine. Yeah.
Okay. My answer is 1, 2, 3 are same, 4, 5, 6 are same. 1, 2, 3 are same because resonance is applicable. If resonance was not applicable, then yes, technically 2 and ideally speaking, he should not have put the goddamn double bond there. If it was me, I would have put the double bond at a different location. Let's say I was going to be looking at this here. Instead of 1, 2, 3 being given that way, I would have used 1, 2, 3 like this. Double bond over here. Instead of putting it here or here, I would have put it here. So, I mean 1, 2, 3, 4, and 5. And each side may say 1, 2, 3, 4, and 5. So, in this here, if you put it over here, have a look now. I would have put it like this. Then I would have asked you, are they the same?
Resonance is not applicable here.
Yes. So what will happen now? Now your sir's logic will perfectly apply here. तो समझ रहा है कि मैं क्या बोल रहा हूँ? So this will be the cis fellow, this will be the transcript. So in this case, the question would have been better.
In this case, the geometrical isomers.
Yes, in this case, the example works perfectly. The only mistake which was made was he did not recognize it. Resonance can play spoil sport there. You do not have to worry about resonance playing spoil sport. But if this was asked in your exam paper, some teacher will make sure they remember resonance plays spoil sport. So, all right. Next, any other doubts there? Any other questions? Any other issues which you've had so far in your current week's discussions?
1 second. So does this one exhibit geometrical isomerism? Isn't it?
You understood the alkenes and all those cases properly?
Oh, yes, sir. Yeah.
Properly?
Yeah. Yeah. Oh, you're talking about the planes and all, like.
Yes.
Odd
I am
number.
talking
Yeah.
about the planes and all. Yes. I am talking about the planes. I am not talking about just the answer there. I am never talking about the answer.
Yeah, understood, sir. Yeah.
Send, bro.
I sent it. Oh, it's still loading.
Yeah.
Yeah, no.
What do you want on this?
Does this exhibit geometrical isomerism?
So, in this particular case here, this system is going to be something. Was it asked, does it show stereoisomerism, or was it asked, does it show
geometrical isomerism?
Very clearly asked about geometrical, right?
Yes. Yeah, specifically that.
Technically, yes.
So
But the problem here is it is going to be a little bit awkward, mainly because these are not going to be on the same plane. Because the ring and this will probably be on opposite planes. If they are not going to be on the same plane, then it is not going to be geometrical isomerism. It will then become optical isomerism applicability. It will be a different game at that stage.
Sir, I sent the full thing.
Yeah, I saw. So what is asked here?
Which of the following exhibit geometrical isomerism?
Okay. So this guy no. 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 This guy technically yes. This guy no. This guy also no. But this is where things get a little bit interesting here. Only this guy seems like it. Remaining are all no's. Now, why are these guys no's? 2 are same here. 2 are same here. 2 are same here. 2 are same here. These are all not applicable. So only this one here, you're having this side and this side being different, and you're going to be having this side and this side being different.
So in the 7th one, how is it? 7th and 8th one, can you explain again?
H2 and H2, no? Hydrogen, 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 hydrogen. 2 are same, right?
Oh, yeah, right, yeah. Sir,
you have to have different on both sides.
If you don't consider the CH2 part and you only consider the ring and the two methyls.
That's not the way it's supposed to be, right? Because from the rings perspective, if you're going to be taking ring ke liye tumhe kya chahiye? You should not have a double bond there. Oh, apdi baat hai na, you are correct. Yeah, that way I am the one who made a mistake here. I'm very sorry. These two will show cis-trans.
Will show what?
These two will show cis-trans. They will show ring cis-trans.
Oh, cis and okay.
Ring geometrical.
Yeah, okay. Like
this part there is no geometry.
Two structures ones.
So the answer would be, you want me to draw the two structures? Okay.
Yeah.
So be warned, this is not the correct way of drawing the structure. Effectively, this is where things will be better if I'm showing you the molecular models. I assume they have started with that, but it looks like you have not yet started with that. When you're going to be having a molecule, if I'm going to be taking this ring as a planar species, all right, let's say it's planar right now. If it is planar, then I can effectively have one group above and one group below. Technically,
Yes.
that is
Yeah.
carbon, 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 carbon. They're all on the plane.
Yeah.
That's the assumption. So if they are on the plane, then there will be one group above, one group below from your perspective here.
Correct. Yeah.
Right. So if I'm tilting it like this, then one group towards you, one group away from you. Correct?
Yeah.
So
yes.
How can I make them cis-trans? I can have one CH3 above, and this CH3 is also above.
Yes,
Or,
and H is inside.
Yeah, H is going to be away.
Yeah.
You're familiar with this Sawhorse projection or not?
Like the dash and
Wedge and dash.
Ah, yes, I know.
You know what wedge and dash. What
Yes,
do you understand by the
yes.
wedge and dash?
That means the dark dash is like coming towards us. Pretty much they're like going away from each other.
So effectively, you're going to be having a tetrahedral carbon taken. When you're going to be having any tetrahedral system,
like this shape. Yeah.
yes, so you're going to be having this is a tetrahedral carbon here. So this is a tetrahedral system. Okay, so this tetrahedral system over here is something where you're literally going to be having this like a camera tripod. Literally, it's a camera tripod. I'll just show you my damn camera tripod here. You understand? Not camera tripod, the light tripod. This is the lights tripod.
Yeah.
Which is pretty much the exact same as the tetrahedral, not exactly the same angle, but yeah, more or less. So this is going to be a tetrahedral carbon. So when you consider a tetrahedral carbon, there are many ways of representing a three-dimensional figure in 2D. All right, there are many different ways which are adopted normally. So when we are talking about different ways of drawing a 3D structure into 2D. So drawing 3D to 2D. There are many ways of drawing it. One such way is going to be your wedge dash. So solid wedge and dashed wedge or hashed wedge, whatever. So effectively, the 4 bonds on this single carbon here. Let me put different colors on each of them so that it is more clearer to an extent. So if I'm going to be having this as the compound here, all right, as you can see, this is something where there is nothing on top here, nothing here. So it's a hydrogen, and 3 random fellows are there on the tetrahedral carbon. So this molecule, how can I show it to you, or how can you draw this molecule? If I'm asking you to draw this, you can see it now in 3 dimensions. How do you draw this? How would you draw this? How you draw it would be, you take 2 on a plane. Let's say I'm taking the nothing and the blue on one plane. This is going to be the plane where I'm going to be having, as you can see here, the nothing and the blue are on my palm, on the plane of my hand. So I'm going to be having them on the plane of my hand like this. What's going to be happening if it's like this from your point of view? You can see that the red is coming towards you, but the red is blocking the white. Correct?
Yes.
The red is blocking the white there. So the red is blocking the white there, and simultaneously, from this angle, if you look at it like this, from this angle over here, what is it looking like? It looks like the white is blocking the red in this case.
Yes.
Correct. So there's one bond coming towards you and one technically going away from you. So look at it like this plane now. So this is the plane right now. So from this plane's point of view, if my viewer was here, right? So if the viewer was on this side here, the red will be coming towards them. While the white is going to be going away from them. If the viewer is on this side, the white is towards them, the red is away from them.
Yes.
Correct? So depending on the angle of the viewer, you're going to have to draw. So when you're drawing a 3D shape, you will draw it as, let's say this hydrogen is going to be here, blue over here, and I'm going to be having, let's draw this guy now. What's happening? The blue and the hydrogen are on the same plane now. Red is on this side, white is on this side. So from your point of view, the red is coming towards you, the white is going away. So effectively, the one which is going towards you, you will be putting it as a solid wedge.
Yeah.
And the one which is going away from you, you put it as a hatched wedge. That's basically the idea here. This is basically called as sawhorse projection or wedge dash projection. You'll be learning more about this before you go into optical activity. So pretty much the next thing you'll be learning after the optical activity part there will basically be this only. Because without this, you cannot go into the next thing. You'll be learning 2 or 3 ways in which a 3-dimensional molecule can be converted into a 2D image, which can be drawn on paper. You need to learn how to draw these structures because you'll be given only those structures. And you have to get comfortable with them.
Okay.
And that's going to be the game. So, all right. And how comfortable are you with... they've just started this wedge dash for you, I suppose, yes?
No, we've been doing it for a while.
You've learned Newman projection?
No.
So you'll be doing it only now. You have not learned it then. They're just showing you that so far because that is easier. And you have learned that in chemical bonding, maybe thoda sa, but no, you're going to learn them again now in a proper. So when you have learned them, after that, we'll sit and discuss them. Now, any doubts you had collected over the week? You understood the 7th and 8th over here, I suppose, yes?
Yes, sir, yeah.
And the 6th?
The 6th one. Oh, yeah, the 6th one, can you?
The 6th was in this direction. Here and here are different. Here and here are different.
Okay, that, yes. It's like a AB and then CD. Yeah. Sir, but so you just consider the upper part to be some, but then they're attached, no? Would that make a difference?
How does it make a difference? You're having here there is one, here there is one. These two sides, if they are the same, there is a reason to not bother. But this side there is a CH3 here. So this side and this side are different. This side and this side are different.
Correct? Okay, that's what I was thinking.
And there is going to be inhibited rotation over here.
Yes, because of the double one, yeah. Yes.
Next.
So, how, like, there are a few formulas for the number of geometrical isomers, right?
No.
I mean, for like simple ones.
Oh, no.
Oh, I had one more doubt. I forgot what this is. Oh, sir, the question
avoid memorizing too many formulas. If you're memorizing a formula, you're going to get a few formulas from here. I'm guessing you were given a question of this sort.
Hello?
Let me make the question up so that you realize that, yeah, that is possible.
Yes, sir, yeah, your video got stuck.
You got something like this as a question?
Yes, sir, we've done this, yeah.
Yeah, I figured. And you are told directly apply formula, get the answer.
Yeah, find the number of sites which...
Yeah, I'm not going to change that. Apply formula, get your answer.
Okay, sir, I have one.
I'm not going to change it.
Okay, sir, there's cyclobutane And then there are 3 carbons, so not 3 chlorines, my bad.
Number, name.
Okay. So 3 chlorines anywhere. Like just
Number, name.
okay, 1, 2, 3
Trichloro on which
trichloro.
carbons?
1, 2, 3 trichloro.
2, 3 trichloro. Cool.
And then CH, double bond CH, CH3. Oh, sorry.
Name the group. Name the group.
Prop 1 in oil. Sorry, oil. Oil.
Prop 1 mean okay now. Okay. This guy?
That's it. Yeah. Yes.
Okay.
So the answer, like with my logic, was tallying, but then I'm not sure if it's correct. So what I thought
What
was,
was asked?
the number of geometrical isomers.
Okay.
So what I did was, so the ring and the double bond can exhibit geometrical isomerism. So the like in the formula, n value will be 2, right? Like
Sorry.
so there are two possible sites in which can exhibit geometrical isomerism, right?
Let me interject for a second here. Your question here was number of geometrical isomers for this compound, correct?
Yes. Yeah.
Now, do not apply a formula.
Yeah, I'm not. Yeah.
Do not.
Yes.
Logically break the problem down, solve it.
Yes.
Formulas are going to be useful when you are going to be having, what to say?
Simple.
No. When it is going to be exactly the same type of case where you are told the formula works for that goddamn sure.
Okay. Here it's a doubt.
The problem with the formula is formulas are highly fallible.
Limited.
Very, very limited. So never, ever think a formula which is given will work everywhere. If a teacher has taught you a formula, they should absolutely tell you where the fuck it doesn't work. At least. Yeah, he would have told you where it doesn't work. These cases, avoid using it, or he would have told you only in these cases use it. Your job is to actually take it like Vedavaka. Only in those cases, use it. Don't think too hard. Your teacher has basically struggled through, has seen that these cases are being asked stupidly regularly because some bugger in some place is getting irritated and is asking stupid, shitty questions. And these guys are also basically using it in exams.
Yes.
And the actual way to do it is complicated, time consuming. This is easier to get it done.
Yeah.
Now, you will get another set of formulas when you're going to be doing optical activity soon. I'm quite sure he'll be giving you. If he's giving you for this, he'll give you for that also. My recommendation, don't come and ask me for those formulas and how they work. I avoid formulas like a plague. I do not like formulas because they put a bad filter on your brain. They limit your thinking.
Makes sense, yeah.
And I like freedom in my thinking. I do not like to control. Now, let me go with your question here. These guys will show geometrical isomerism.
Yes, that's
like
okay.
Now
So,
up-down type of. So, when you're going to be having these 4 groups, all 4 of these groups can do up-down type of shit. So, don't think about this geometrical isomerism. That is not going to be the thing. That is never going to be the thing. This ring wala geometrical isomerism is going to be the key thing there. So, start off with the numbering part here. So, let's say this is going to be 1, 3, 4. Okay. The way to go about it is go with up, 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 up.
Yes, that's right. Up, up,
flat,
up, down.
Up. That is the way to proceed and understand. Eliminate out groups. This is funny, fellow. These are all chlorines.
Yeah.
Now you can check in these numbering also, because if this is 1, 2, 3, 4, the same thing can be in reverse also.
Yes, exactly. If it's these two, it's the same as,
The way to identify number of geometrical isomers in these kind of cases, actually sit down and do sets and get it done in a mutually exclusive manner, which is pretty much the same goddamn rules you've been following till now. Correct?
Yeah.
Do
Yes,
the
sir.
same principles. Go back to first principles. This, what to say, formula approach and all will work for people who are not capable of doing the first principles work.
Mhm.
What you should do here is, when you are tackling these kind of questions, you should effectively try both. Your teacher has done the hard work and found out that formula works in some cases, correct? So you will try out the actual approach like the way I just showed you now. You will also try out the formula approach and see if they match up. Why? Because you will add data to yourself. If
When
the
they
formula
match up, when they
is in
don't.
some cases, it can expedite your time if that same stupid case shows up in an exam.
Yes. Yeah.
But you will
Yes,
not
sir.
bank on formula. So you will actually physically try out different cases by the proper method, see if it matches with formula, then decide, okay, this is matched with formula. I have confirmed for myself, so I can blindly use formula. You test it out for yourself.
Okay.
There is no other approach there.
Hmm.
Fair enough?
Okay. Yeah.
So
Yes, sir. Yeah.
I basically
Sir.
did try all that nonsense when I used to teach. I realized it is just not worth memorizing formula. There are so
Okay.
many tiny cases which will
Hmm.
screw you over, where there will be sudden symmetry appearing. Suddenly, one or two cases numbering will be in reverse direction. You should not add, you should not count them. Formula generally takes into account quite a few of those things. I do not deny that. It will give a much more cleaner answer. But I never trusted formulas well enough. That was my mistake also, probably. If you are convinced by formula, which your teacher has taught you, my recommendation is sit and try the approach which I just showed you here, the up-down type of shit. You will get the same answer. This will be far more satisfying. But it is going to be longer. There is no question of that. It is going to be longer. It is going to be consuming more time. So if you find the formula working for quite a few of these cases, some of them at least, and you work them out, please share them with me as well. I'm also curious to know where all this works. If you can reduce my labor properly, why not?
Yeah.
Why not? Huh? Certainly. So, that's
Sir.
basically what I would say about formulas there. Yes.
Sir, in this example, I didn't really use formula, but then I want to know if this method is valid. Like, so from there are two, like you consider the double bond and the entire ring, there are two sides of, they both exhibit geometrical isomerism. So from those only the possible cases will be four, right? Like one, yes, like one exhibit, one doesn't exhibit, like that. Four cases will come, right?
Go on.
So and then again three chlorines are there. So they have three chances to be front, back, front, back, front, back. So can we do 4 into 3 into is equal to 12? I'm getting the same answer. Like, so does that make sense? Or is there a possibility that if the carbons are front and back, you have to see with
Effectively, what
respect to
you're
the
trying to
chain?
say is,
Hello? Hello?
this itself, along with
Yes, sir. Now I can hear.
guy and this guy. So this part, along with this and this, you counted, you got 4.
Yeah.
Then you realize you'd count this also and this also.
Yeah, the chlorines as well. Yeah.
But then why did you multiply by 3 then?
Because there are three cases, like this one carbon could be front, the middle one could be front, or two of them could be front.
See, the thing here is why you multiplied by 3 is not based on that then.
Why?
I am not going to explain that part right now. That is something you will understand a little bit more once you have done a little bit of optical isomerism. Your answer is not wrong, but not for the reasons you think. In a sense,
Okay.
what did you do? You did 4 yahan se multiplied by 3.
Yeah.
Why? Because you have accepted that यहाँ पे A, B, C, D structures आ रहा है, तो यहाँ पे 3 जो structure आएगा, हर structure के लिए there is going to be an A, B, C, D applicable.
Exactly. Yeah.
Correct.
Yeah.
Now, how did you arrive at the 3?
The
The
chlorine.
3 is correct. But the 3
Then
is actually because these two fellows, 2 and 4, chlorine here, can be up, which is the same as down in some cases, or it's like this, up
down.
will become down, or it could be that the up down is going to be the same as the down up.
Yeah.
What will happen is, in one case, you'll end up having, that is among the A and B. For A and B, you'll probably be having this 2 plus one of these happening. Let's call this as what to say, case.
So again, cases apply here. Okay.
No, you're not understanding the game here properly. What actually happens, I'll tell you. For A and B, I will have, let's call these as number 1, number 2, number 3, and number 4. Roman numeral fellows. Okay. For A and B, it will be 3 cases, which will be 1, 2, and 1 of 3 or 4. Because 3 and 4 will both be the same, or something of that sort.
But why?
1 and 2 will be both the
Then
same.
in that case, 1
and 3 and 4 will be different. No, you're not understanding the point over here still. You took that 3 like this. I'm telling you the 3 is not like that.
Okay.
You did 4 into 3 blindly, correct?
Yes.
You did 4 into 3 blindly, right? My internet connection is unstable. Oh, fuck. Okay. So you did 4 into 3 blindly without recognizing why you are doing multiplying by 3. What I'm trying to tell you here is that 3 is not easy to get.
Oh.
You're overestimating your 3 there. Right now, it is a goddamn lucky guess.
Okay.
That's all it is.
Okay.
So that's what I'm trying to explain. You're having 4 structures A, B, C, D here, correct?
Yes.
A, B ke liye you will get 3 multiplied by 3, and B, C, D ke liye you will be getting multiplied by 3. But the 3 for A, B will be different from the 3 for C, D.
Sir, how do you know that it can be 1 and 1?
No, because I know you'll have to sit and try when you have learned some optical activity and some optical isomerism. Okay. Once you have learned that a little bit more in detail, you'll understand what I'm trying to explain here. For now, the idea is this. In A and B, mostly up will become same as down. For carbons 2 and 4, the chlorine is there. And in the other case, up down will become the same as down up. When the up down becomes the same as down up and down will be different. When the up and down are being the same, then the up down and the down up will be different.
Yes. Yeah. Okay.
Let me put it like this. Currently, what's the 4 structures you got? Think.
The inner one, like 2 possibilities are there, no? Like this.
Right? In this group, I can have a cis or a trans.
Yeah.
Correct?
Yes.
This was 1 into 2.
Again, the double bond can show.
No. Double bond is cis or trans is done.
Oh, the ring, no.
Then this will go here.
Okay, understood. Yeah. So again, 2 more cases.
This was the first one.
Hmm.
Okay, so this is your other 1 into 2. So this is
adding
your
4.
A, B, let us say. This is your C, D, let us say. Or this could be A, C, B, D, whatever. Now, where are your others coming? The others are coming over here and here.
Yes.
Right? The chlorine, okay, this is a 4-membered ring, not a 6-membered.
Yeah. Even serious.
But yeah, you get the point.
Yeah. Yeah. I got it. Yes. Yes, sir.
Huh? Yes, sorry. So group chlorine. So this can be cis or trans and hydrogen group cis or trans, chlorine above and hydrogen below. Now you're going to be having chlorines present on the other two fellows there, correct? So when
Yeah.
you're going to be having chlorines present on the other two fellows over there, let's talk about one thing here now. If I have, say, chlorine here
Understood.
up and
Okay.
chlorine here up. And if I put the same chlorine here up and the chlorine here up, are these two going to be the same structure or different structure?
Different.
No, they are same.
How?
If this was cis
Oh, no,
over
no,
here
no. Same.
and this was
Same,
cis
same,
over
same.
here, they'll become the
Correct.
same.
Same.
Because
Same.
this side and this side will now be the same. That means these two
Yes.
are technically not going to be cis-trans there.
Okay. So that's why you're removing one of the. Okay.
You understand the point now? In this case,
Yes,
the
sir.
up and up are different than down and down. All right. So here the up and up are different. So the up and up are same here, but these two are going to be what? So here this was up over here, this was down over here. So this up and this down makes them the same.
Yeah. Yeah.
Effectively, if I had up, 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 and an up over here and a down, up here, these are both same.
Yeah.
समझ रहा है कि मैं क्या बोल रहा हूँ?
Yes, sir. Yeah.
So that is going to be the type of thing which you need to start weeding out.
So, or I think easier method would be like you can just take, instead of that entire group, you can take some like other simple one thing and then multiply by 2 again.
I am not saying you can't do it like that. That is what I'm doing also over here. Basically, you arrive
It's
at
much
how
easier
many
like that.
possibilities are there in this and then multiplied by 2.
Yes,
Because the
that's what I'm
group will
saying.
have
6
cis-trans.
into.
So it is actually 6 into 2, not 4 into 3.
Yeah, 6 into 2. Yeah, 6 because the CL, and some other group.
You understand the
And then
idea
into
there?
2. The
So better
yes,
approach
I
for
got it.
this is
Yeah.
actually not 4 into 3, but 6 into 2. You go 4 into 3, you are going the dangerous approach there.
Yeah, lengthy approach. Yeah.
You understand why I was not happy with your 4 into 3 there? If you had gone with
Yes,
6
sir, yeah.
into 2, that is a far better approach, which is more foolproof. 4 into 3, the complication which comes out over there is which 3? For which 4? For which ones?
Yeah, correct. Yeah.
And understanding which ones is going to be a complicated game there. So that is basically the key there. All right. So I hope you understood what I'm talking about there in that particular case. It's been too long already. I'll have to shut up. Any other last minute questions?
No, sir. No,
You still seem to have something on your goddamn brain, but
no sir. Nothing.
Okay, all right. Next session will be more or less a continuation, I suppose, of this. As I said, go with questions. Any question, doubts which you're having, from what I'm seeing, you are quite competent in organic. It's not a problem at all for you. Your understanding seems very clear. So go with your doubts, settle your issues first, as in when you have them. If there are any things which I find you will need to know to understand better, I will obviously poke.
Okay.
Okay then, good night.
Yeah.
Have a
Okay,
good
sir.
day.
Thank you, sir. Yeah. Good night, sir. Bye.